the first question is, we have a new word. So what's the new word that you see on the board? Maybe it's not new to you in terms of the English language, but it's a new math word. What do you think is a new math word up here? Limits, that's exactly right. So the question is that we need to ask is, what is a limit? And why do we need them? So I'm been trying to set the answer to the second question of the past 2 days. So if I've done my job the past 2 days, you'll know hopefully the answer to the second question. The first question is, what is a limit? Okay. So let's review. I'll kind of zoom in on that particular graph that we talked about in the last lesson, the 4x, or I think it was 4x minus x squared. And we said that if we wanted to find just the slope at 1, if we zoom in, okay, so we want to find the slope here. Do you remember what I told you the slope was? I gave you the answer. Remember, we kind of guessed at it. Do you remember what the slope was? You know, it's in your, we did it yesterday. The slope is 2. Okay. All right. I told you the actual slope. So we know that that's the answer. So now the question is, how can we get to that? If we need how many points for a slope? That was the discussion, right? So how many points do we need? 2. So here's what we're going to do. Let's take this concept. I'm going to scooch down, so let's just say 2 is here. I think 2 would have been the peak. I think the peak was at 2. I'm going to scooch a little bit over here to the right. This was the conversation we were having, Eli, when you pick a different point. So if I pick a point over here, and I just make this line, and what type of line goes to 2 points? Forgot, what's that called? Secant line. And we found this point. Let's just say we went here at 1.5, okay? We're not going to do it, but I just want to talk about it real quick. Do you have enough information? If we say x is 1 and x is 1.5, can you get the red slope there? Do you have enough information? What do you need to get slopes? 2 points. So if you have x's and you have the equation, can you get the y's? Yeah, we can see that f of 1 is 4 minus 1, which is 3. F of 1.5, you could plug and crank real quick, just see what it is. 4 times 1.5 minus 1.5 squared. Quickly, how fast are you? If you can text 17,000 words a minute, you can do this. It's got to be something bigger than 3, less than 4. Okay, so there you go. So we got 2 x's, 2 y's, boom, we can get it. All right. If I now, instead of using that point, if I move maybe a little closer, like we said, instead of maybe taking 1.5, what if I went to 1.1, this blue one here, and did that? Will the blue line be closer to the slope of the tangent line than the red line is? Yes, it's going to be closer, right? So instead of doing that slope there, if we did f of 1 is 3, and we do f of 1.1, and we get that one, I think we can get a better estimate, whatever 1.1 is. I mean, we know we could do that. Could we choose an x closer than 1.1? Could we find something closer than 1.1? What is closer to 1 than 1.1? 1.01, so that's real close. So I'm kind of running out of colors here, right? So if we kind of just erase this and just kind of think about it. So again, our goal is to get the slope of the green line. So see if we got like a nice magenta or something, or orange, or anything. We got Santa Claus here. We got a brown. Okay. So 1.1, maybe we're here now. Oof, that one's dead. Yeah, so, here we go. Oh, I'm sorry, we said 1.01. 1.01's here, so real close. So if we pick a second point very close to that point, we're gonna get closer to this slope. Would we be in agreement with that? Can we go closer than 1.01? What would be closer? So these are a whole lot of bunch of slopes that we'd have to get. But we want to get closer and closer to what x? What x are we trying to get closer to? 1. We're trying to get closer and closer to x equals 1, but don't reach it. Because if we reach it, if we do f of 1 is 3, and we do the same point again, what's going to happen when we plug in the slope? Indeterminate, 0 over 0. So the idea of getting closer and closer, but don't reach, the word that, anybody know the word that we would use to get closer and closer to something, but don't reach it? Starts with an A. It's a very good answer, but I'm just thinking English language, because you're right, it's the same idea. If I'm going towards something, what am I doing? It starts with an A. Approaching. The word we use in math to get closer and closer to something is called approach. So we want to learn how can we approach but don't reach something. Because I want to approach and look to see what a pattern is, look to see for a trend. And then we can hopefully come up with a good answer to that slope there. So we're gonna put this on the back burner. And I'm going to give you a problem to show you why we need to approach and why we can't just go to the actual number and see what happens from there, okay? So you're gonna see that this approaching relates to what limits do. So does everybody see the reasoning here why we want to approach this other point? The closer we get to it, the closer we get to what? The slope. And what's that slope called when the line touches one point? Tangent line. Well, that's the name of the line. Okay. We're going to put this on the back burner. Luckily, it's on tape, so you can come back and look at this. So now, let's take a problem that looks harmless. We're going to take this function f of x is x squared minus 4 over x minus 2. Okay? And the first thing I want you to do, I want you to find f of 2. Do f of 2 first. So what happens? It is indeterminate. Very good. So just to remember, anytime we get 0 over 0, it's like we just can't get an answer, okay? And the technical word for that is indeterminate. So we did 2 squared minus 4 over 2 minus 2, we get 0 over 0. That was the one number we could not plug in, correct? Right? Is there any number you can't plug in? Is there any other number that's going to cause that? The only way you can get 0 over 0 is if the top is 0 and the bottom is 0. Look at the bottom. What's the only number that makes the bottom 0? 2. So is any other number okay? What do you think? Can you think of another number that we can't plug in?
No.
Okay. Yeah. So that's the only number that we have a problem with. All right. But there is a graph to this. And what we want to figure out is, okay, well, here's the thing. I don't know what the y value is there, but could I at least try to get close to 2 and see what those points are? And maybe that will tell me what point is close to 2. So I can't actually plug in a 2, but I can at least get close to 2 to see what point is close to it. So here's what we're going to do. We're going to make a table. This is in your practice there. That's 1.2 JIT. I don't know if that's the good word for it, JIT. Sounds like Jedi Institute of Technology to me, is what that sounds like if it's JIT. So what we're gonna do is this. Let's pick X's that get close to 2. So we're gonna approach X is 2, and we're gonna see what the Y's goes, what the Y's equal. So give me X's that get close to 2. What X's could we pick? It's Ivan, right? Ivan, give me an X's that continuously get closer to 2.
2.01.
Okay, so he's starting what side of 2? If you think about it on a graph, is he to the right of 2 or to the left of 2? To the right. We're gonna do both sides. So he's got 2.1, 2.0. Now we gotta get closer. What's closer than that? 2.001. Very good. Now you got the idea. So I like that he didn't do 3. He's like, I'm just gonna get close to 2. Let's do 4. So 2, you gotta do 2 more that get closer to 2 in the same trend. Do 2 more X's that get closer to 2 in the same trend that you're doing. So you did 2.1 or 2.01. You did 2.001. What would be better than that? Yes, 2.001, 0001, 30. And let me rewind, and let's just do 2.1 for the first one, okay? So there you go, you got 4 there. You're gonna plug those in and see what your Y's are. Okay? See what the Y's equal. I don't need you to tell me the answers because I already know them. I don't need a calculator. So, you can give me the first one, then I'll give you the other 3. What's the first one? 4.1. It goes 4.01, 4.001, 4.0001. That's what you should have got. You plug it in. Okay? So, I know those other 3 in my head. Obviously, there's a what? Yeah, a shortcut, because I did the math in my head, but that's a pattern. So look what happens here. The X's, what would you say is happening to X's? The X's are doing what? What's the key word for today, other than limits, the A word? Approaching what number? What are they getting closer to? So the X's are approaching 2. The arrow in math means approaches. Arrow in chemistry means yields. Arrow in mathematics means approaches. So as X's are approaching 2, what are my Y's over here? Is there a pattern on the Y's? Are they getting closer to something? They're approaching 4. But notice there is no 0.24. Because I can't plug in a 2, because when I tried to plug in a 2, what happened? Indeterminate. Now, in your homework in the JIT where you're just doing the tables, there may not be a pattern. You're just getting practice at tables. But I'm trying to show you, I'm introducing what concept today? What am I introducing? Limits, okay? Let's do another table, because that's not the only way to approach 2, is it? What's the other way? Yes, from the left side. Very good that you said left. So what X's can get close to 2 from the left of 2?
1.9.
There you go. That's exactly how we'll do it. Usually go a tenth away. Because 1.9 is pretty close to 2, but not right on. Then how do you get closer now? Just add a what? Like here we added a 0. Here all you gotta do is add a 9. 1.99 is much closer. 1.999, then 1.9999. Okay, and let's see what happens. We'll check our work in a second. So you should only have to type the x's in. If you once you type this into your calculator, I would have typed this into y1. So I'll put this in on my calculator, go to y1, type this in. I'll pull it up on the calculator in a second, but when we do another problem, I'll go to my table and I just type my x's in, but I would use the table feature. So now 3.99, 3.999. Is there a trend? 3.9999 on the last one. So again, at the very bottom, I'm going to write like a little, if I see a pattern. The pattern for my x's is what? X's are still approaching 2, and the y's are approaching 4. But is there a point 2, 4? Does that exist on this graph? No, because when we plugged in a 2, what happened? Just the whole thing went to shambles because we got 0 over 0. So what you have just done is you've just done a limit. What a limit does is tells you what the graph approaches when you can't reach a certain point because it doesn't exist. That's what a limit can do. So what the limit has done is it's told us the trend of the graph. We kind of know what's going on around it, around that point. Okay, so here's what a limit looks like. You'll see LIM. So what I've done is I've done the limit and now I'm going back and answering the question. So all that you did over there, you just did a limit. You'll see this LIM means see what let the x's approach and you put an arrow. I've made x approach 2, and then inside of it you put your function x squared minus 4 over x minus 2. And that says how you read this mathematically is the limit as x approaches 2 of x squared minus 4 over x minus 2. And so what it's asking is, it's asking for an answer. You figured out the answer. You know what the answer is. So x's are approaching 2. What you're looking for over here, what do the y's approach? So what did the y's approach? What did they get closer to? 4. And that's the answer to your limit. Okay? Both tables have to have 4. So as you approach from the left and the right, you have to get the same answer. Okay? You have to get the same answer. We're going to do another one in a second. But that's the introduction to limits. So why do we need limits? What's the reason for them? I hope with the little tangent line problem we saw, sometimes you can't put another point on top of it. You want to approach something, right? And when we look at this graph, you'll kind of see what the graph, why that's happening. So I'm going to graph this for you. Does anybody know what this graph looks like, by the way? For plus 300 bonus points, minus 300? Very simple. It's a linear function. It's a line, yes. So we're going to erase this. Okay. We'll do another one in a second, maybe, if I have time. So this graph, if I look at the function here, notice one of the F words of mathematics that students usually struggle with, one is fractions, one is factoring. We have both here. If you can factor and you can handle fractions, you can reduce this. Difference of two squares. X minus 2, x plus 2 over x minus 2. That's what gives you your 0 over 0. That's what was blowing it up when you plugged in your 2. That ratio, most of the time, if I plug in any other number, is going to give me what answer? This ratio. What answer do I get? 1. If I plug in a 5, I get 3 over 3. I plug in a 7, I get 5 over 5. That's 1. X plus 2. That's your line. It's the line x plus 2. Looks like this, except at 2, you can't plug in a 2. So guess what's at 2? A hole. That's what an indeterminate form happens. That's your graph. So basically what we've done is, Ivan, the x's you gave us on this side. So we picked points that got closer here, and we could see that we were approaching this y value 4. And then somebody gave me the 1.9, I can't remember. Brewski, was it you? Brewski gave me the 1.9. And we approached from both sides, and we can see that we were approaching the y value 4. We can't reach 4, can we? We can't get there. But that's okay. Limits don't tell you what's there. Limits tell you what you approach. So a limit, what is a limit? It tells you what do the y's approach from both sides, and it has to approach the same answer. Why do we need them? Because sometimes we need to approach something without reaching it. Okay? From the tangent line example. All right. Now let's do a legit limit. Let's do one more. All right. There you go. Now, anytime we deal with trigonometry, make sure you have your calculator in radian mode. So now you have a trigonometric function. Make sure you're in radian mode, okay? All right. Now, we're going to let x approach 0. So let's talk about our table real quick. We're going to make two tables. How do you approach 0? Well, how did you approach 2? You said 2.1, 2.01, 2.001, correct? We'll take the 2 off. Approach 0, what would you pick? 0.1, 0.01, 001, 0001, and then on the other side, just make those what? Negative. Negative 0.1, negative 0.01, negative 0.001, negative 0.0001. Look for the trend on the y's. Make sure you're in radian mode. Take a couple of minutes. And now that is and you're looking to see what do the y's approach, and they must approach the same answer to have the answer there. You're looking for the trend, okay? So you will need calculators for this homework. Okay, can somebody give me table 1 so we can check our answer? Who can give us table 1? Alyssa, you look like you got it.
I got 0.99833.
Good. 0.99833, okay.
0.99998.
All right, good.
And then the next two are just 1.
put your cursor on the right and see what it says, because it's just rounding. It's probably 0.9998, and then 0.999998. Okay, so is there a pattern? What are the y's going to? 1. Here's what has to happen, guys. Real quick, look up here, give me your eyes for a second. The y's over here have to approach 1, or then we have an issue, then it's disjointed. So we're looking to see if both sides of the graph narrow in on the same area. Okay? So what did you get here? You should have got the same answers. Exactly the same. You should have got 0.99833. Yeah, they should be exactly the same. Oops, 4 9s, 5 9s. All right, you should have got y's approach 1. So what is the answer to this problem? What do you put for your answer?
Y approaches
Y, so you just put 1. The question is, what do as you let x's get close to 0, what do the y's approach? That's what the limit is asking. What are the y's getting closer to? So you're looking for, you're not giving 0.999, you're looking to say, hey, this is what they're getting closer to. And notice that 0.01 does not exist. Because look, if I try to plug in a 0, what happens on the bottom? You divide by, can you divide by 0? No. So that point doesn't exist. There's a gap in the graph there. So this graph, whatever happens at 0, it's getting close to 1. So it's kind of like this right there. Okay? So you've done your first 2 limits. So what is a limit? Let's make sure we look at this statement. As we let x's approach a number, the question is, what do the y's approach? That's your limit. Questions. What happens if this doesn't go to a number? Right? What if there's no pattern? Then there's no limit. And we'll look at that. What if this one went to 1 and that one went to 5? Again, then you would just say it does not exist. Okay? Why do we need them? I talked about the tangent line problem. What we need to get closer to something else without touching it. Because once we touched it, remember what happened with those fractions? You got 0, and this is actually 0 over 0. Because if you plug in a 0, sine of 0 is 0, and then you get a 0 on the bottom. You get 0 over 0. Okay. So for get here where I can see everybody. So for you guys here and the guys at home, you should be doing 1.2 JIT, which is just on tables. The tables will not have a trend. It's just doing tables. And then now we've started the first part of your limit assignment, which it's not due yet, but that's what you should be working on. Okay. All right. And that's it. Okay. So